right? If this system was in row echelon form, then we would expect that it will look something like this, right? There would not be any terms in these three positions. Okay. So the process by which we convert this to a row echelon form, if you remember the list of methods we have to solve systems, there was one called Gaussian elimination. That's called Gaussian elimination. And in Gaussian elimination, you use elimination, right? What we just did in the last lesson, but you kind of using it inside of a bigger system. For example, I need to have this be blank. We expect that in row echelon. So what I'd look to do is some combination of row operations, meaning multiply one by a constant and add it to another, just like we do in elimination, so that it cancels these two terms. And then I'll put the result in that row. In that way, it'll have the characteristics of both of those equations in one. It's an equivalent system. So what combination of these two could I do that would eliminate this? How about if I just add them, right? X plus negative x cancels. So the first step would be, let's add the first and the second equations, like we do in elimination, and put the result in the middle row, right? So that is, add these two, and put the result in the middle. Now, we won't change the first equation or the third equation. They stay the same for now. So the first row is still x minus 2y plus 3z equals 9. Okay, the second row we're going to replace. We're going to replace it with the sum of the first and second equations. X plus negative x cancels. So just leave it blank. Negative 2y plus 3y, y. 3z plus 0, 3z. And 9 plus negative 4, 5. Okay. And then 2x minus 5y, the third equation didn't change yet. Okay, so we cleared out this spot. Now we need to clear out this spot. So what combination of multiplying a row by a constant and adding rows would eliminate the 2x? Yeah, if we multiply this by negative 2, then negative 2x plus 2x cancels. So that'll be the strategy. Let's multiply this row by negative 2 and then add it to this row and put the result in the third row. It's like you're not going to see the row which was multiplied by negative 2, right? We don't take a step and multiply that by negative 2 and write that there because we really don't want to change this. So what we're going to do now is let's multiply this row times negative 2, add it to this row, and put the result here. Okay. So the first row itself will not change. X minus 2y plus 3z equals 9. Y plus 3z equals 5. Okay, now here's the row operations. Negative 2 plus times x is negative 2x plus 2x cancels. So this is blank. Okay, negative 2y times negative 2 is 4y. 4y plus negative 5y, negative y. Negative 2 times 3z is negative 6z. Negative 6z plus 5z is minus z. And negative 2 times 9 is negative 18. Negative 18 plus 17, negative 1. So now we've cleared out this position, right? We got one more to go. We need this to be blank, right? So what combinations of row operations could we do that would eliminate that negative y? There you go. Just add these two up and put the result here, right? So we're going to put it here because we need this to be the blank row, right? This one is good like it is in the row echelon form. So let's add these two and put the result in the bottom. So the first row doesn't change. X minus 2y plus 3z equals 9. The second row doesn't change. Y plus 3z equals 5. And now the third row, y plus negative y, cancel. 3z plus negative z, 2z. And 5 plus negative 1, 4. So it's not quite what the first one said, only because it doesn't say z equals 2. But we could solve that one first, right? Because it's one equation, one variable. Solve that first. And then this system, that is the system that we just solved. Right? That's how you put it into that form. You do row operations until you've got the row echelon form, and then you use back substitution to solve.